All right. Good morning and Happy New Year to everybody out there. Thank you for joining us again today as we bring in the new year here, continuing our tech webinar series that we started last year. My name is Anthony Connors, and for those of you who don't know, I'm the regional field engineer for the Michigan and Toledo area, and I'm going to be your host for today. So we always like to just kind of go over a couple of things you might be noticing here if you're new to these types of events. Probably have already noticed this, but your camera and microphone have been turned off. And on the right side of your screen, you should be seeing a handy Q&A feature. If you have any questions that come up during the presentation, you can feel free to submit them there with your first and last name as the presentation is going on, and we're going to take some time at the end of the presentation here to answer your questions. If you don't see this function or it's not working for you, you can always email your questions to solutions.michigan@swagelok.com, and we'll add your questions to the list for our presenter. But with the intro out of the way, I would now like to welcome back Chris Kiesling here for joining us again. Chris is a chemical engineer with over 15 years of experience in the field before he joined the Swagelok team here 2.5 years ago as our operations director, which makes him the perfect candidate to take us through the webinar on leak detection. So without further ado, I'll now turn it over to Chris.
Yeah, hey, thanks, Anthony. And again, Happy New Year to everybody. It's great to have everybody back. Hopefully everybody's safe in 2021. Had a great holiday. All right, so topic at hand today is leak detection. Hopefully, if you're on this, you realize that you're not going to learn anything here that is going to tell you that that's a leak. Hopefully, you already know that that's what leaks look like, and those are pretty big ones. But our goal here today is going to be to look after our smaller leaks or look for areas where we can improve. And also, we're talking leak detection. I also like to think of this webinar as a little bit of leak prevention as well. So we're going to talk a little bit about things we can do on the front end of our installations to prevent leaks and have a leak-tight system over the course of the system's life. So we always start off with our what, when, and why. So our goal here, what we're doing is finding and eliminating process, utility, and equipment leaks, and again, preventing leaks when we do an initial install and we're building a piece of equipment. When we're going to do that, we're going to do that as part of our normal maintenance routine, part of our operating routine, and part of our installation practices. The reason why we're doing that, our goal is to reduce cost and improve operations down the line over the life of the equipment or the system. And also, we want to try to include yields if at all possible. We don't want to have any sort of product loss. So generally, what we're going to look at today are our main topics. We're going to take a general approach towards leak testing programs. How do we do that, and how do we look for leaks or look for issues out in the field? We're going to talk about what to look for when we're conducting a survey. Then finally, we're going to go over some detection methodology and quantifying results. And along with that, we're going to go through a few things that you can do on the front side to prevent leaks down the road. So why is this so important, right? So first and foremost, I always like to start with, I guess I skipped over safety here in a certain sense, but clearly if we have toxic or dangerous materials we're dealing with, safety is an important concern, but then also environmental requirements. A lot of times in facilities, I worked in a plant where we had LDAR requirements. So LDAR is a program, it's an EPA level program that requires you to go out and take leak detection tests and certain process lines as a percentage of your plant basically every year. And we're required to keep that up and keep monitoring and look for potential issues all the time. So that's an expectation of continuous improvement. And again, anything environmental really is both environmental and safety. The environmental is the first, regulations are generally the first step in community safety for our facilities and our communities. Secondly, is efficiency. So we want to have, we mentioned yield loss on the first slide there. We want to make sure that we're getting the highest possible yield and the highest efficiency we can out of our facilities. But also tied to efficiency is cost. So inefficiency is going to add more cost to our operations, and that's probably one of the biggest ones here. So we have an example here. This was from a survey that was conducted here in the Midwest. Again, looking at different types of leaks across tube fittings, pipe fittings, flanges, looking at valve features, and observed about 1,000 total observations or total points, and found maybe about 10% of them or so were leaking. Now that added up to quite a bit, right? $137,000 was our approximate annual cost of leaks when we calculated it all out. So we're going to walk through today how we go about those types of surveys, how you can do those surveys yourself, and again, how do we calculate that cost factor so we can understand what the advantages we're getting from our program is. So how do we go about the surveys? So this is generally a common process. and I'm just going to walk through this and just some things to think about. So hopefully it'll help you guys as you're developing your plan for your situation. But first thing you want to do is identify any key process areas. We want to base that on cost or product loss issues. So examples of reasons that we want to investigate, for example, if we had, say, rising compressed gas costs, right? So if you have maybe a tank of liquid argon and you see that prices or the cost overall is going up and up and up while production's staying flat and your price hasn't changed at all, that would imply you're losing material somewhere. Another possibility is increased boiler demand or increased air compressor cycles. So if the air compressor is cycling more frequently or using more fuel on your boilers and you haven't increased production and nothing's really changed in the facility otherwise, it would imply that you're losing air or you're losing steam somewhere. So that would imply you have leaks someplace. So once we identify our key process areas we're going to focus on, next thing we want to do is create a tagging system so we can identify our issues later on. One of the things I always give people advice on is make sure that your tag color makes sense based on what your plant standards are. So I have it right here. It can be this simple, just the date, the tag ID number, so you can keep track of it in your log sheets later. A little description of what it is, so if someone finds a tag later, they understand why it's there. We use blue a lot of times because we see that blue isn't used for things in a lot of facilities. If blue means something in your facility already, don't use it. Similarly, if you use orange or red, a lot of times that means danger or lockout or something. So you don't want to use a tag that means something else because it can give people a false understanding of what's going on out in the facility. So next, now we have our tags set up and we've got a group of tags ready to go. We're going to generate ourselves a log sheet. So that's basically so we can take note of what our findings are when we get out in the field. This is an example of some of the things you might want to have on your log sheet, just the date, your name, what area of the facility you're working in, or what piece of equipment you're working on, what your system media is. So if you're going after, say, nitrogen or argon or something, you want to include that so you can calculate costs later on. And then we're just going to number our observations, tie that back to our tag ID number, and record what our leak size are and a little bit of the location of exactly where it's located, like maybe what process line it's on or exactly where on, say, a valve you're finding it, but also a little description of what you think the issue is. And then finally, we want to follow up with service requests or work orders as necessary to correct our prioritized list. So once we prioritize things, we want to make sure we do that final step and put in those work requests. Now, once we go out in the field, what techniques do we want to use for leak testing? So before we start, we want to make sure the process is in service and or pressurized. So again, think about things like check valves, any sort of things that controls directional to make sure that you are pressurizing your entire system and you've got pressure everywhere. Then once we do that, where do we want to look? Well, first and foremost, we want to think about things like threaded in connection. So over here, we've got an example of a threaded in connection with a tube adapter going into a tube fitting elbow. So we want to take a look at those threads and investigate those for any possible issues. Next, we want to take a look at our tube fittings. We do the tube fittings, we want to look at both sides of the nuts around the compression fitting. That's going to help us identify any sort of leak. Sometimes you'll see it on one side versus the other. But again, we want to take a look at those as well. Flanges are pretty important. Every flange is going to have a gasket on it, so we want to make sure the gasket integrity is good and we're not having any sort of issues at our flanges. And then valve packing. So valve packing is actually probably the biggest thing that we see on surveys that we do. And part of the reason why is because valve packing needs adjustment periodically, and a lot of people miss that. So the valve packing is going to be what seals the moving part of the stem against the inside, the material going through the body of the valve. So that valve packing is going to be underneath the handle, kind of like we pointed out there on these 90-degree valves. Or in the case of this gate valve, you see the packing gland is right here. It's where the stem is traveling through. A lot of times you're going to see something like on a gate valve, you'll see this sort of boss right here, and there's an adjustment nut that you have to adjust periodically to keep the packing on there. That's going to wear out over time because the stem of the valve drags against the packing itself. Now, other things to consider, this photo I love because it shows this is a valve with a bonnet on it. So there's a bonnet seal right here. So you want to keep an eye on things like bonnet seals. Don't forget those. Hoses, if you have them out in the facility, do visual inspection or inspect those frequently. If you have cracks and things on the hoses, that's not indicating good things. Your piping in general, you want to do the best look you can at piping because you can have leaks at things like weld points on a piece of pipe. Then finally, quick connects. Don't forget your quick connects. A lot of times, if you have a quick connect on the process that's sitting uncoupled all the time, that's got a little tiny, basically it's a check valve in there that could leak by over time. So make sure you're keeping an eye on those as well and looking for possible leak points there. So that's the areas we look. Now, how do we look? So here's some options on detection equipment. First and foremost, probably the most accurate and the most detailed is using something like an ultrasonic gun. These are pretty common units. They are very, very accurate and they can find very tiny leaks. The con side of this, though, is that you're going to have special training required to use it. The results can be very hard to interpret. So on top of the training just to use the gun, sometimes you need some training to interpret your results. Also, it's very expensive. This is probably the most costly out of all the tools that we have listed here. Second, I've seen this before in a lot of facilities, is visual. So just going out looking for things. Steam leaks are pretty easy to find, especially in the winter visually, or using gas detectors. So a lot of times this is like an example of a 4-gas detector. You know, the pro of this is inexpensive. A lot of people already have them in the facility. It's pretty easy to complete. The hard side of this one is it's hard to quantify how big your leaks are. Not all leaks are detectable as well. So in the example is the gas detector, it's kind of detecting what it has available, you know, the 4 sensors, but that's all it's looking for. The other thing is safety. So if you're going out with a meter like this that's got a VOC detector on it, if you're going to go out and try to look for a leak on something that's a volatile line, the problem is you're putting yourself in some level of danger to go out there. So it's not the safest way to go about things because, you know, essentially the gas detector is there to protect you from those materials that could be in the environment. So our final possibility is liquid leak detector. So Swagelok's branding, this is Snoop. Again, this is pretty commonly used. There's a lot of options out there. Snoop is a very popular product for us because it's so easy to use. It can detect very small leaks, and you can actually quantify those leaks somewhat. It's inexpensive and very easy to train people how to use it. The con side of it, though, is that the quantification is not highly precise. So you can get an idea of relative size of leaks, but it might be hard to quantify exactly how much leakage you've got. So we're going to focus on that liquid leak detector size. So I did some videos here to kind of show you how we use this. The good news about liquid leak detectors, it gives us, like I mentioned, a relative size estimate for the leak. So here we've got some different options where we have argon at 200 PSI. So our first video here, we've got a leaking fitting down here at the bottom of this T. So when we go in with the Snoop, we want to go and just kind of sweep across the joint. The nice thing about Snoop is that it doesn't tend to foam up very much, so you can see it looks very clear. Now, it might be hard to see in this video, but there's just some very fine bubbles right here. In fact, I came back in, as you can see, put a little bit more Snoop on there to try to see if it's easier to see those bubbles forming. They're so hard to see that I said I should probably record a second video here. So on the right-hand side, you'll see those tiny little bubbles forming along that joint. So those bubbles, this level of leak, we would call a small leak. So a lot of times when we quantify our leaks, we have a methodology to calculate the volumes. So we put this through a volume calculator, and we figured out this is about a 0.01 CFM leak. So about 1 cubic foot per minute of argon lost because of that leak that we have there. Now, our methodology is based on a paper written by Dr. Arthur M. Sterling called Fugitive Emissions from Tube Fittings, Prevalence and Magnitude. Again, that's pretty widely available. You can go and research that yourself and grab those volume calculations and that information. So these small leaks of about 0.01 CFM, again, pretty hard to see, but you can detect them with the Snoop. Now, here's an example of a medium leak. So you can see this is going to bubble up right away. You're forming much larger bubbles. Now, I'd mentioned you want to sweep both sides of a nut on a compression fitting. This is the reason why. You can see we didn't really see anything on the side, the valve side of that nut, basically. But the other side, we see a lot of bubble formation. So we want to check both sides every time we're doing any sort of leak detection. So this one here we refer to as a medium leak. Again, this is more like a 0.02 CFM leak using the same methodology. Finally, we've got our favorite, the large leak here. So you can see the bubbles form very large. Again, that's how we can tell the relative size. You can see bubbles on both sides of it in this case. And again, the bubbles keep growing and growing and growing. So that's an example of a large leak. So that's estimated about 0.04 CFM. I want to take one last shot. You can see some of our leak in the background there, but this is more to show what it looks like when you don't have a leak. I figure we should also show the positive side. So a leak-free fitting, it should just run off just like water. Now, at times you can get a little bit of foaminess with the Snoop if you shake the bottle up or something. Again, if you get little bubbles from foaminess of the material, just rinse them off with the Snoop. They'll travel right away. Again, you're looking for continuous generation of ongoing bubbles. So after I swept this, I said to myself, well, could we have found this any other way? So one of the things I want to point out is the use of gap inspection gauges. So on our no leak side, I use the gap inspection gauge. So hopefully people are familiar with this. Generally, when we install tube fittings, we want to do 1 1/4 turn. And that's how we know it's tight enough that we're going to be leak free. To double check our work, we can use a gap gauge. So we use this on any piece of equipment that we build in-house. We do our normal turn 1/4, but we always double check all of our fittings with a gap gauge. So on our leak-free fitting, that was the one with the N written on it, you'll see there's no leak and the gap inspection gauge doesn't fit. So that indicates that we did everything correctly on the install. So that's exactly what we expect. We went to our medium and small leak. You'll see the gap inspection gauge fit inside there. Well, that means we've got a problem. It should not fit, okay? So again, I didn't have to go all the way to leak detection. I could have just used my gap inspection gauge and know that I didn't tighten things all the way. In fact, on one of these two, I also didn't bottom the tubing out far enough, and that's an important thing to look for. I'll mention that later on in the presentation. Now, finally, I thought, well, I should probably gap gauge my large leak here, and let's see what that looks like. Well, the gap gauge didn't fit in my large leak, so what happened? That's a little confusing. So I took that joint apart. Well, I already knew what happened because I'm the one who prepped it, obviously, for this webinar. But what I found is the ferrules were way over tightened. So this bottom photo here, that's going to show ferrules that are taken up correctly. It should give about that appearance. You see a little gap between the back ferrule and front ferrule, nice conical shape, and that's about what we expect to see. Well, this one I way over tightened it intentionally. Then when I reinstalled it, it wasn't able to be tightened enough or correctly to prevent the leak. So you can see the ferrules are crushed together. There's a little bit of deformation of the ferrules there, a lot of shininess on the material. So again, I was able to diagnose it, but it also shows the gap gauge isn't necessarily always the last word in it. It will tell us if we installed it correctly the first time, but it's not necessarily going to tell us down the line that we've tightened it up enough to prevent the leak. I also want to include in here a little information on good practices. So when we're initially building something, again, this gets back to leak prevention. This is an example of a system that we did for a customer. And one of the things we did was we used multiple color marks. So it's maybe a little hard to see down here, but each of these nuts has actually 3 marks on it. There's a green, a blue, and a black mark. So I zoomed in on these so we can see it a little easier. So what this means in our system, these are VCR glands. So green means it's good to go that there's a gasket installed and it was hand tightened. Blue means that we tightened it up to full tightness. In the case of VCR, it's a quarter turn. And then black was put on by the person who was leak checking. So again, it gives us a visual afterwards that we know that it's been installed correctly. It's got the right sealing material in there with the gasket. It's been tightened up fully, and somebody has leak checked it when we did our initial check before we sent out to the customer. So again, a nice practice you can use when you're building equipment or installing a system when you're double checking or when you have someone else double checking for you. So let's pull this all together here, right? So we're going to make sure our logs, we've logged what we have. We want to make sure our logs are recommending what to fix on the problem. So some of the things you might want to recommend when you're logging these is to adjust valve packing if you find the valve packing is leaking, replacing a component if you think you've got a bad component, or maybe it's a gasket or an O-ring. If you see those types of things, again, be as clear as possible so you can keep track of it. Another thing you want to do is make sure that you don't forget to communicate your results. So a lot of times, as we showed in the last one, things are installed incorrectly, and that goes back to people just not knowing the right way to install it. The better you can communicate your results, either say maybe in a daily startup meeting or any other sort of place, you can help other people not make the same mistakes later on. So we want to be clear, we want to be honest about that and communicate what we're finding in the field so we all learn together. Finally, we want to use the leak cost determination and recommended repairs to generate cost savings analysis. So to calculate leak rate, I just want to walk through the calculations here really quick. So we use our large leak example. So what we said was about 0.04 cubic feet per minute, CFM. So we're going to multiply that by 60 minutes an hour, 24 hours a day, and 365 days a year, assuming it's running continuously. That means that we're wasting about 21,024 cubic feet a year of argon. That amount, I went back to our, that was off of a tank of argon. So I went back and found that we pay about 4 cents per cubic foot of argon. So if I multiply that 4 cents per cubic foot of argon times 21,024 cubic feet a year, that's a cost to us from leakage of approximately $840 a year. That's from one fitting. We're losing that much argon in this case. So pretty easy to justify going in there, buying a new fitting, or just buying new nuts, a new nut and new ferrules, and reswaging those up to get a better seal. Again, these can be huge savings on just going out and making leak corrections. So one final thing, some common problems and solutions, just some things to look for or think about on tube fittings. I mentioned it, one of the fittings I found that was leaking. This is a very common thing that we find when we do surveys for customers, tube fittings that are not fully bottomed out into the tubing. So you see here where the ferrule ends right at the very edge of the tubing. What we should have, as we showed in the last or in the other slide, is we should have a little extension of tubing that's going into the fitting and fully bottomed out. Again, you could get a very good initial seal, but it's going to affect your seal down the line as you reuse the fitting over and over again. So one way we counteract that is we have depth marking tools. So you can insert the tubing into the depth marking tool and make sure it's bottomed out, put a mark on there, and then when you slide into the fitting, it'll show you that the tubing is fully bottomed out and you're not going to have an issue. NPT, so this is a kind of a photo of a bit of a mess here. But again, leaks caused by system vibration is something we see very frequently. Another one is lack of proper sealant or enough sealant applied the correct way. So remember, NPT threaded fittings, they always seal on the threads, but you have to use an additional sealant. And one final thing to remember is that liquid sealants have a cure time associated with them. So make sure you're following manufacturer recommendation for how to apply those and how long you should let that system cure before you pressurize it. And finally, on valves, packing leaks, like I mentioned a couple times right here, that's very common. One reason you can have that is material selection. Well, we've had some webinars on material selection and valve selection already. You might want to go back and take a look at those to learn how to select the right elastomers or the right materials that are compatible with the fluids in your system. But then also remember that valves will need on packing periodic adjustment. Biggest thing here you want to do is follow your manufacturer specifications and recommendations on valve adjustment. Make sure you're not over adjusting or over tightening those because it can cause drag on the stem and cause you more problems down the line. So again, always follow the manufacturer recommendation. And please, if you have to replace or even adjust a packing, never loosen valve packing glands when a system is pressurized, and never try to change packing out on a valve when it's pressurized. You're basically you're disassembling a seal at that point, and that can be very dangerous. So we want to keep an eye on that. Make sure we're never ever loosening pressurized packing glands. So finally, how can we help? So we're in Michigan, Toledo. We offer leak detection services. So we have field service, fluid system evaluations and advisory services, or we can have visits from Anthony, our field engineer, or other folks in our engineering team. We also conduct energy audits. It's a little more basic version of our FSEAs. We can come out to your site and just do an audit over your whole facility and take a look for what kind of issues we might have. There's training services available to ensure proper installation the first time. So we do a lot of training classes. We were doing some last week. That the goal here is that we do it right the first time. So this is great whether you're maintaining a facility, operating the facility, or if you're building equipment. Those training services can really help to make sure things are done right the very first time. And hopefully we touched on a little bit of that here today. Then finally, system evaluations. The system evaluations are available to go over what you're currently doing, your processes on install. We can also come out and do an evaluation of your designs or your product selection to help you make sure you're selecting the right product for your specific solutions. So to review what we were trying to do today, we're looking to identify and eliminate leaks in our facilities and on our equipment. When we're going to do that, we're going to do that as part of our routine maintenance and operations, but we're also going to do the right procedures from the very start to make sure we're installing things properly at the very beginning of the process. Our goal here is to ensure a consistent operation and to save money down the road. And remember, we're here to help. So please reach out for deeper discussions, or if you want to schedule a meeting so we can discuss how we can support you. And with that, do we have any questions?
Yeah, awesome. Thanks, Chris, for all of that. So we'll take some time here to answer some of the questions. It looks like we have a pretty big list here, so we'll try to get through all of them if we can. But as always, if you do have a question, you can use the Q&A feature on the right side with your name, and we're going to add it to the list here. But just go ahead and start rolling into them here, Chris.
Okay, I'll try to talk fast. I'll keep them short.
Yeah. All right. So first question here was a pre-submitted one from Brian. And Brian is saying, my primary interest is that I'm working on a project dealing with vacuum, and I will need to detect leaks there. Any tips?
Okay, yeah, that's a great one. So I didn't cover vacuum today, obviously. I could go all kinds of different directions with leak detection. So vacuum, there's a couple different options. If we were working on a system that we wanted to prove out vacuum here in the shop, we use a helium leak tester. Now that's a pretty expensive piece of equipment. If you're building the same thing over and over again, and you find that you're always kind of building and proving a piece of equipment before it leaves your facility, that might be an investment you want to make. A helium leak tester allows you, we do what we would call on a vacuum system an inboard helium leak. So you would draw a vacuum in your system. You would take a hose connect up to your helium tank with the pressure reduced down, and you would essentially blow helium over the outside of each one of your joints. Then you would hook up your helium leak checker, your helium detector at the discharge of your vacuum pump, basically. So that would then be seeing if there's any helium being pulled into your system. So you check each joint one at a time, basically, that way. Now, that's a very accurate, very fine detail way of doing it. Another option is you can do pressure decay testing. So we can do this on positive pressure. We can also do it on negative pressure. So generally what you'll do is hook up a pressure gauge to your system, make sure the system is fully sealed, and draw it all the way down. Now, if you're trying to source out and figure out where the leak is, you're going to need multiple pressure gauges so you can isolate different legs of your system. So shut it off with a valve, draw down the system and see if that individual part is losing pressure or losing vacuum, basically. So in that case, you'd be gaining pressure, right? We'd be going back to full pressure. The final way you could go about it, you could try doing a more coarse version of a helium leak test. So again, draw your vacuum down and then use something other than helium to measure the discharge of that vacuum pump. So you can see if whatever you're spraying essentially around the outside of each joint is coming through the vacuum pump and being pulled through the system. And again, if you need more help on that one, best bet, reach on out, or we can reach back out to you. I know it was a pre-submitted question, and kind of go over some of the methodologies we've used in the past.
Excellent. Yeah. So next question here we have from Chip, and Chip is asking, can we detect water vapor leaking into a compressed air system?
Sorry, I muted my microphone for a second there, and I lost my mute button. So I tried to take a drink of water. So I guess water is appropriate here. So yeah. I'm trying to detect water vapor leaking into a compressed air system. In that case, you're going to have to try to use some type of moisture analysis on there. Again, I think that one thing you could try doing, I'm kind of thinking on the fly here, Chip, but you could try doing something. There are desiccants that are essentially for drying air. You could try to take a desiccant cartridge inside of a clear tube. They make them that color change as moisture flows through them. You can take a very small, thin tube full of color change desiccant, hook it up, and essentially blow the air through there at different points in your system. I assume what you're trying to do is find where the water, the moisture is getting in. So each one, you could basically let them run for a certain amount of time with a little bit of air bleeding through it, and then look for which ones had the most color change, or use that to back trace essentially the different branches of your system to try to figure out where's this stuff coming in at. Again, over time, you could probably do something similar where you're I guess testing or leaving them in place and timing out how long it's taking for the desiccant to change color, fully in the tube. That's one way of doing it. Another thing is you can buy, if you want an online monitor or online probe, you're going to look for a moisture sensor. I'm trying to think of the exact name for them now. But again, a lot of people make probes that you could put online or install in your system. Again, we'd be happy to help you with that. If you get a metallic probe, at times you can do things like use a nut and ferrule combination to essentially directly install it into your system. So love to follow up with you and help you out more on that.
Yeah, excellent. So this one's come up a couple times here, Chris. A couple people are asking, is Snoop just soapy water?
Oh, that's a great question. If you've been through any of the class I teach, you'll know that I always tell the story that I never really used Snoop before I came to Swagelok. We used to always just have one of our interns go up to the dollar store and get a bottle of dish soap, and we'd mix it up in a 5-gallon bucket and just mop it on the pipe. Now, the problem with that I found is that you get suds kind of everywhere. So you see a lot of foaminess all over the place, and sometimes it's hard to see exactly where your leak's coming from. Snoop is a very specific blend, and so it's not all the same components of soapy water. So basically what we're emitting is the material that makes soapy water foam up. So ideally what's going to happen is you saw it on those little tests that I did. The Snoop's going to come out of the bottle very, very clear. And what we're trying to do is create a situation whereby it foams up or bubbles up only when there's a leak blowing through it. So again, it gives you a lot more resolution. You're not going to get as good a fine detail and be able to tell the difference between small, medium, and large necessarily with a soapy water mix, and you're not going to be as consistent with it. And again, sometimes it's hard to tell, and on top of those suds tend to stick around. Where with the Snoop, the bubbles will kind of wash away. You'll either form new bubbles or more bubbles, or kind of end at that point. So again, a lot easier to detect very small leaks with the Snoop, and a lot easier just to do leak detection in general. I found it's really, really easy to use.
Gotcha. Yeah. Okay, a couple more here. Hopefully, try to fit in. Next one is from Paul V, and Paul is saying that he's got a valve that he thinks is leaking by the seat. Does the info still apply to that? So I'm guessing over the course of the presentation here.
Yeah, so leaking inside of seats, that's more like an internal leak. So what we talked about here mostly was kind of external leaks, right? We talked about vacuum, which is a form of external leak of air leaking in. And we talked mostly about pressurizing, so material, product, or whatever it is leaking out. So what about an internal leak? That's a great question. So I'll jump back to one tool you can use is our ultrasonic testing equipment. The ultrasonic testing equipment, if you get really good at it, you can actually hear, using the headphones, the flow of material through the pipe. So my assumption here is you probably have a bunch of valves and one of them's leaking by and you're not sure which one it is, and you just want to check for that. So what you're able to do is just go a little bit upstream of the valve and a little bit downstream of the valve and see if you've actually got flow in the pipe. So what you'll do is there's a specific probe you use the headphones, you put the probe up against the pipe, and you can actually, through the ultrasonic testing, hear the material whistling through, basically. And that's what we're going to want to listen for and check for and make sure that we stay ahead of. So that's probably the best way to see inside. Again, you know, if you can block it in some way or another, you could try to do pressure gain or pressure reduction. So you could try to pressurize a part of the line, close that valve, put a pressure gauge on there and see how fast you have pressure decay. That's another way to do it without ultrasonic equipment.
Yep, exactly. All right. Well, unfortunately, we're hitting our 10:30 mark here, so we're going to kind of cut questions short. If we didn't get to your question, we'll be following up by email. And if you have a specific question that wasn't answered, or you always come up with one later, you can always feel free to follow up with your account manager. But just a couple things to end on here. So after the webinar, we'll kind of be sending a follow-up email with hopefully some pretty useful reference documents. The first is a blog post to our website. The post will cover a lot of information on leaks, some of the stuff that we covered here today, like the cost, some of the causes, the types, and testing to test those leaks. And then we're also linking another post and a video. Both of these cover the importance of the tube preparation, which Chris went over, and should hopefully prevent most of those vastly common leaks that you'll see out there. And as always, we always like to highly encourage you to take advantage of our technical team here. We're always ready to help you with your specific applications and selections, so feel free to reach out. And be sure to join us for our next webinar featuring gas distribution systems. This webinar is going to be on February 18th at 10 a.m. again. And for any questions, concerns, or feedback regarding the webinar, please email us at solutions.michigan@swagelok.com. And I want to thank you all for joining us today and kicking off our webinar series here in 2021. And for more information about our webinars, please feel free to visit our website at michigan.swagelok.com. Thank you all again for joining and have a good rest of the day.
Yeah, thanks, everybody.